This lesson is on geohazards. A geohazard is a geologic event that has the potential to destroy property and cause a loss of life. And when we're talking about a loss of life, we're talking about human, plant, and animal. It may also have negative and or positive effects on the environment. Almost always, the immediate effects are negative, and there may not be any positive effects associated with most of these geohazards, but for some, there can be long-term positive effects. All right, geohazards include landslides, earthquakes, tsunami, sinkholes, and flooding. A landslide occurs when debris separates from bedrock and the material slides rapidly downhill. This can be caused by oversteepened slopes that are just too steep to support much soil or other things on top of them. It's just too steep, and it's just too easy for gravity to take control and bring material downhill. The removal of vegetation, as we talked about in previous lessons, vegetation such as plants and trees, their roots help hold soil in place, and without them, soil moves a lot easier. So oftentimes when trees or other plants are removed from a slope, the soil becomes more loose than it was before, and it's easier for it to come down the hill in a landslide. Earthquakes can shake material loose and make it come down the hill. This can cause huge landslides, such as you see in the picture here. That's likely the cause for this landslide. You have a mass movement, a big bunch of soil and everything that existed on top of it and in it coming down this slope and covering up this roadway. Also, oversaturation of soil on a slope. So if you have soil on a slope and too much water soaks into it and makes it very heavy, it can then come down the slope in a landslide. Whereas otherwise, that soil, before it was weighed down with all that water, was not heavy enough to come down the slope. Ways to avoid landslide damage. The best rule is to avoid building homes or businesses or other buildings on areas of weak soil, particularly slopes. It's really never a good idea to build on slopes. Plant trees and other vegetation in areas that might be prone to landslides. You just have to be careful with that and choose the vegetation properly. You don't want really heavy trees on a slope, because it may actually make the likeliness of a landslide worse than it might have been. You probably want to do lightweight plants with good root systems. Spraying slopes with concrete to reduce rock slippage. That's an option, such as you see in this picture, but as you see, it's not all that nice to look at. It's kind of an undesirable way of controlling landslides, but sometimes proves necessary, such as the scenario we see in this picture, because given enough time, this slope would continue to erode away until it took these houses with them. All right, earthquakes. Earthquakes occur when tectonic plates slip and release seismic waves. I'm not going to talk a whole lot about earthquakes because we had a whole lesson dedicated to earthquakes, but we can talk about ways to mitigate earthquake damage. Unfortunately, there's not a whole lot you can do, but if you live in an earthquake-prone area, you can secure the shelves in your home so they're not likely to fall over. Now, things may still fall off of them, but at least the whole shelves won't come down. Securing gas and water heaters, items like that might be dangerous if they come loose. And also, like I was saying in the earthquake lesson, in areas that are prone to earthquakes, it's more and more common that construction companies are utilizing specialized construction that helps control against structural failure and the collapse of buildings. All right, volcanoes. Again, this is another one we had a whole lesson dedicated to, so I'm not going to talk a whole lot on. But volcanoes, like we said before, they can release dust and ash, which can alter the climate by blocking out the sun. Depending on how much dust and ash is ejected, you can have a regional climate shift, or you could have a global climate shift if the eruption was large enough. Um, Volcanoes can also trigger mudslides called lahars, and also lava can come down the mountainside and threaten people and ecosystems. All right, here we have a contour map that represents a volcano. On a contour map, each line represents an elevation, and you can see here you have, like, I'm assuming this is in feet. It's either feet or meters. It doesn't say, but we'll just assume it's feet. We have 2,500 feet here, 2,250 here, 2,000 feet here, 1,750. So you can see that as you go away from the crater of the volcano, the elevation is going down. Okay. All right. Now, when you see lots of lines like this, that means the slope is gradual. But when you see not very many lines, that means the slope is a lot steeper. So you can see here you go from roughly 2,500 and maybe even a little higher down to, let's see, what does this belong to? Straight down to 2,000 right here. Okay, whereas here you have at least another step in between. So this brings up the question, what side of this volcano, if you couldn't avoid building near this volcano, which side would be safer to build on? And in the case of lava flow, really this side right here would probably be safer to build on. Of course, as far away from the volcano as you could be, but on this side, because the slope is more steady, the lava would likely flow slower on this slope and give you more time to evacuate than on the northern slope here. It may come down a lot quicker because you have a much steeper slope. Tsunamis. Tsunami is a large tidal wave that is generated by seismic waves released from an earthquake. These are caused by a slab of crust being pushed upward in the ocean. It thrusts water upward with it, and then when the water comes back down, it flows outward in every direction. And then as the water reaches shorelines, it builds into a larger and larger wave as the seafloor rises up to, basically the continental shelf and then the actual land itself. Tsunamis travel from 500 to 950 kilometers per hour, so they're very quick. Like, there's not a lot of time to warn for them when they occur. And also, if you were on a ship out in the ocean, a tsunami wave could go right up under the ship could ride right over it, and you wouldn't necessarily even realize that it was a tsunami wave. It's only when they start to get closer to the shore that they become very dangerous. Here we can see a piece of oceanic crust thrust upward, and you can see that the water goes upward, and then when it falls, it flows out in every direction from that spot. All right, ways to mitigate tsunami damage. First one is to preserve dunes on beaches. These can help absorb some of the impact and keep inland areas from being damaged. Also, building trenches to divert water. There's certain types of systems that can be constructed that when the tsunami wave hits it, it kind of sends the water in different directions to kind of break up the flow. Also, you can build seawalls such as you see in this picture here. These can absorb some of the impact. They can also just keep the wave from coming up over top and flooding the inland areas. But in the past, in Japan, there have been tsunami waves bigger than expected that have overridden these walls and still flooded inland areas. So, some of these things are going to help, but they might not be totally tsunami proof. All right, sinkholes. A sinkhole is a natural depression on the Earth's surface. Basically, it's a hole that forms naturally. Sinkholes are typically caused by the collapse of rock that is underground because it's been chemically weathered by groundwater. So when we were talking about chemical weathering, we showed pictures of the inside of the caves and talked about how caves are formed from the chemical weathering of that rock that the caves are made out of. So if enough chemical weathering happens to bedrock and leaves a void underground, the everything on the surface above can collapse down into that void because there's not enough structurally underground to hold the soil and everything else above in place. So you can have a big mass move, everything falling in at once. Now, this picture you see, this sinkhole here, this one's obviously quite old because it has vegetation on the bottom of it now, and trees growing up out of it. So that one's not a new one, but you can see this one is rather large. And when it opened, it likely opened all up and fell all that, collapsed in at once. All right, mitigation, ways to avoid or lessen the impact of sinkholes. Pump out groundwater that dissolves underlying rock. If there's an area and we know there's groundwater that doesn't necessarily need to be in that area, you can pump it out, and it will keep that groundwater from performing hydrolysis on the bedrock below, and hopefully keep a sinkhole from forming. Carefully inspecting bedrock, using ground penetrating radar to make sure there aren't any voids down there that could lead to a collapse. Also, if there's ever water on the ground from a rain or from flooding and there are bubbles rising vigorously through the water, that's a pretty good indicator that you have an underground void and may suffer a sinkhole in the future, because what that means is that as the water is flowing down into those voids or those spaces, empty spaces, it's forcing air out. So the air's got to run out of those spaces so that the water can get into it. So you have these vigorously rising bubbles in the water, indicating that void underground. Also, as you see in this picture, you've got some roadway that has fallen through and taken this car with it. And you can see here you have like a sewer access, and you have some pipes. So anytime pipes leak, they can lead to sinkhole activity. And we've actually, our little area of the state here is not terribly prone to sinkholes, but we have suffered some, and most of the ones I've heard of are due to some kind of pipe failure, either a drainage pipe or some sewer pipes of some sort. All right, groundwater pollution. Groundwater becomes polluted when chemicals seep into the ground. A general rule is that any substance that ends up on the ground ends up in the groundwater, and in other bodies of water eventually. So the things that can pollute groundwater, oftentimes when we think about water pollution, we think about something that might have came from a factory or something like that. But for the most part, most of the water pollution comes from the everyday things that we use. A lot of it comes from vehicles, oil, gas, other fluids we use in our vehicles that spill onto the ground. They eventually end up in the water and in the groundwater. Animal waste from farms can end up in the groundwater. The waste breaks down, and rain takes the waste with the water down into the ground. Also, pesticides that we use to keep bugs off of our crops, same thing can happen with those. Chemical fertilizers we put on our crops, they can also end up in the groundwater as well. So whenever these substances end up on the ground and water carries them down into the groundwater, it can contaminate wells and drinking water and other sources we use to get our drinking water from. Rivers, ponds, streams, lakes, so on and so forth. All right, flooding. Flooding occurs over an area where water cannot seep into the soil because that soil is either impermeable, meaning nothing can soak into it because it does not have enough pores, or something is covering it that is not porous and will not allow water to flow through, or the soil is already saturated. It's already holding all the water it can possibly hold. So that's the two things. So in some urban areas, flooding is apt to happen because you have so much what they call hardscape, like you have roofs, and then you have paved surfaces all about the city, and water cannot soak into those paved surfaces. So it piles up really easy. It accumulates and leads to flooding. Furthermore, when you have extended periods where you have lots of rain, flooding becomes a danger because the soil can only hold so much water at a time. And when the soil is totally full of water, none can soak in, and it just piles up on the surface and leads to flooding. Ways to mitigate flood damage is to maintain flood risk maps. This is something that a city or a town may do. They identify locations that are prone to flooding, and then they usually commit those areas to being green areas. They just let those areas kind of stay, nature like. They just let grass and trees and whatever grows in them grows in them. Let whatever animals want to live there, and they don't develop it in any way, because if you develop on those flood areas, you're just asking for whatever you build there to end up flooded. And this was a real problem in Charlotte, and still continues to be, to a certain degree. But there was not really a good plan in place for flood risk, and a lot of places were built where floods were prone to happen, and many times there were floods that caused loss of property and loss of life and other things. Yeah, don't build homes on floodplains. That goes right into the maintaining flood risk maps, proper planning. Redirecting waters through flood channels, that can help too. You see a flood channel here in this picture, and here in this picture you also see a flood channel. These are very helpful in areas that are known to flood, especially ones that are known to flood suddenly and without much warning.